John,
We're
intro.
locking up as soon as you leave.
We are
Okay,
going
we're
to the
locking
Elliott
up
Matsuura
and
Joint
going
Open
out
House
as soon as you leave.
2019. This is like my 7th or 8th time there. Super excited. Always cool stuff to see. Let's go.
I don't think I understood the gravity of this situation, like this show, until just arriving here. I am very excited.
Well, let's go show them what a tool show is all about.
So we're at the Elliott Matsuura Open House. They do have a Tornos GT26, which is just a little bit bigger than the GT13 that's coming. Super excited. So it's good to be able to see it, show it to the guys and the girl, and kind of stick our head inside and see what it's like. So if you remember from our Misfit video, we got Marcus and I forget the guy's name from AeroX. They put the Misfits on both of our machines. They're going to do the mist collector for the Tornos. Super sweet to meet them here and have them kind of look at the machine saying, where's it going to go?
John, I feel like we need more robots.
I think you're right.
Our shop is really lacking in the robot department.
It's like you got our laser sitting in here like this with a light beam.
Yeah.
And each time it goes in, it breaks that beam. The same technology that we put into the laser is also in the probing. So that's what we're seeing here. So we come in, digital signal to find our location, and then if you look here, it's measuring the deflection using analog. You can go in and scan a profile.
Surface something.
You get a master, and then after that, you just come in, scan.
Can you do that on the machine?
Yeah, that's exactly what it's for.
Like with a high time?
So this is a new, this is actually the magic behind it right here. So a lot of guys, especially aerospace, expensive components, this is guaranteed no pullout.
Okay, yeah, because you got the
So
weld
it's,
on.
so the majority of people use Weldon shanks.
Yeah.
So these are very good against pullout in cylindrical shanks. So what we do here is the mechanism that goes in there. So it'll pop flat.
Yep.
You're flat now.
And then you're crimping and keeping it flat.
And then what you have is this piece, you got to take it out of there. So we take the standoff out of that comes in with the hydraulic chuck, and this will go in the bottom.
Okay.
So we throw that in there again.
So it's an installation tool.
Well, it's like a bayonet. This is the installation tool. The bayonet goes in the bottom. It'll bottom up. Oh, sorry, it turned on me. Now I got to get it out. Sorry.
Okay.
But anyway, that goes in there, and then that it's sideways, and then that'll match with this slot in here. So it'll go in there. And a quarter turn, and now you've got full pressure on here. You've got 9 or 10 newton meters, whatever that chuck is.
Yeah.
And then you have complete rigidity. So that's brand new. We just launched this about a month ago.
What's the purpose of this?
So that will make sure that this will hold. It's a double guarantee because you want to make sure that your sleeve isn't pulling out as well.
Isn't pulling out.
So that bayonet will go in there. So I just got to knock it out with something, with a pen or whatever it is. It gets stuck in there sometimes.
Yeah.
I just did it really quick. So that'll go in there like that. Should go like this because I don't have a setup screw. We in? Yeah. So it'll be a torque setting for that.
right.
right?
That makes sense. Okay.
And now it's in there.
So now you've got double pull-out resistance.
Double pull out, and these are always fairly
tight,
right? But it'll go in there.
Yeah, I get it. That's good.
And it'll go in quarter there. So now it's there, quarter turn.
You tighten the hydraulic,
You're done.
not going anywhere.
Microns.
So we've been here for an hour and a half. We've made it about 20 feet, as is always the case. So let's keep walking.
That's Aroa.
Okay. Does it locate right on those?
Yeah.
Why is it overhanging? I never understood that.
Sorry?
Why is it so thin and like, how does it work? It goes to here, right?
This works like this. On a show.
Okay.
And that fits with like this.
So that pulls it down.
Yeah.
But this aligns it.
Yeah.
Okay, so it always stays on a taper.
Yeah. Like this.
Oh, I finally get it. So these are springs, and they always go down to the taper so that they've always got contact and they're always self-centering. There's four of them. Okay, that finally makes sense. You get it? Okay. You gotta unclick it. You have to close it first. Then you finish. The magic of unclicking it really confuses people. Nice. You got it. What do you think?
Cool.
Cool, eh?
Why are you ooh and ahhing over it?
You tell me what is significant about our new pen, the Saga pen.
That's absolutely awesome, man.
We machine every single component, titanium, everything.
Right. So you got to explain to me, because I'm only a simple soul. How do I retract? How do I retract it?
You have to figure it out. I never tell anybody.
Okay, so it's not that. It's not. Oh, there we go.
Nice.
Oh, I like that. That's clever. I'm going to take it apart now, if you don't mind.
Is that a 007 pen?
Yeah, 007.
You'll be recorded. That tube probably comes out.
I guess it's all unscrews.
Yeah, if you take out the mechanism, I think there's like 3 ball bearings that will come out too.
Oh, okay, I don't want to break it then. I don't want to incur the wrath of John. So I better. Yeah, I better.
I like the weight.
Okay, figure it out. Okay, now retract it. This is the test.
Hang on.
Yeah. Keep going.
This way?
No, you're on the right. You're on the right kind of track. You're on the right end.
Oh, okay. So you push that down.
Yeah,
That's
there you
nice.
go. Yeah, you figured it out quicker than me.
I think you need to call Bic. Work out a deal. I like the insignia there too. It's nice.
Yeah.
Sign my name. Let's see how that. Wow. That's smooth.
Satisfying.
Click.
Every component.
Really?
Out of titanium and hardened stainless, and the slider is nickel, aluminum, bronze.
Wow. We're big in the ballpoint pen manufacturing world with Micron. They make these rotary transfer machines for like Bic and those guys. You know, they're amazing machines to watch, really. The two choices you have for one is a mineral oil-based product.
Okay.
One is a vegetable oil-based product, which is canola. So the vegetable oil-based product is really used. Both of them came out of the medical world, which was all titanium and stainless steel and cobalt chrome. And the vegetable oil does all those very, very well. It like will beat a typical normal mineral oil by like 30. You can run 30% faster with it.
Okay.
So, for example,
From lubricity or?
it's lubricity. Yeah.
Okay.
It's, what it is, it's a the way lubricity works. You have different hydrocarbon chains, and they're all sort of floating around doing their thing. And then, as the tool goes over, they lubricate and whatever. A vegetable oil actually has an affinity to the metal. It's a polaric oil.
Really?
Almost like if you could use whale oil, it'd be the best thing in the world you could ever use.
Yeah,
Unfortunately, a little bit of an environmental problem.
You're not going to buy 55 gallons of whale oil.
No. Well, still can actually, believe it or not, but you'd have to go through Russia or Sweden or somebody. But so because it creates a better film strength than the typical mineral oil. Now, the other side of the mineral oil is that we invented a way of taking liquefied natural gas and creating an oil out of it. And basically, you're creating what's called almost like a Mobile One, a synthetic oil, and that matches up all the hydrocarbon chains to be the exact same length. So it takes all the ash content out, all the impurities, and it's perfectly clear. It's also, I don't know if you have a high pressure unit on the machine, 2,000 PSI, 0 bubbles. So it never alarms out to high pressure or anything along that line. The people that work with it love it because it's clear. It looks like water. Yeah. Really, especially in a new machine where you don't have old oil in it. And that's our GT22.
Well, it's going on a GT13.
Oh, it is, really? Okay.
That's funny.
Yeah,
so
it is funny.
What's the basis of that? It's synthetic, it's not...
The reason, it's a synthetic, it's not a synthetic, it's a synthetic oil like Mobile One. That is the same tool life as the Vasco mill in titanium and in stainless steel. It does not perform as well in cobalt chrome. Okay. So you don't care. So as far as the aesthetics go, operator acceptance, 0 foaming.
Because there's the health issues too, right?
Yeah, there's no chlorine. It's chlorine free.
Chlorine and sulfur are the things, right?
All oil is going to have some degree of sulfur in it. The question is it active sulfur or not? Okay. And this contains 0% active sulfur. Okay. Active sulfur. There's like, I think, maybe 0.3% sulfur in it, but that's sort of the natural byproduct of the oil. It's not something that's like in there for a lubricating agent. Okay. You know what I mean? That's just sort of the nature of the beast of oil. It's used everywhere, no skin issues. Operators love it. Don't get it on your head, whatever you do.
Yeah, yeah, it turns out like that.
Yeah.
I really want this.
You guys thinking about me? Yeah. It's a toy, that's why it's cool.
I love it.
The show is awesome. As always, the personal relationships are they're growing. Like I know more people and more people and more people. Like Ricardo here, chowing down on some grub, and it's just really good. And the deeper you connect with people and talk with them, the more you learn, the more stories, the more like little hidden facts about everything you figure out, and that's always fun. Oh, they put it in wrong. It's the wrong way around. It's just a demo, but it was cut on a wire EDM machine. And to show the absolute precision and intricacy that they can get, this is a just about zero clearance sliding fit. Feels amazing. But you can tell the grain structure of one and the other, like somebody put it together in the wrong direction. But it shows the difference. I bet you if we rotated it, it would be better. I'm gonna do it. Such a fit, I don't want to get it wrong. There we go. They're actually made from 2 different chunks of metal, so it's not that the grain will actually line up. But it's cool. So, EDM Machine 101. I don't know very much. Angelo knows more. But basically the wire is electrified and the workpiece is electrified, so they're like positive, negative. And then as it comes, the wire's constantly feeding through and eroding the metal away, like creating micro sparks and micro cutting action, something like that. Very slow process, very accurate, very awesome. Always fun to watch. Be pretty sweet for making some knife parts. Leaving Elliott Matsuura, heading to the 3 other locations. We were here for, I guess, 4 hours, and then we have 4 hours to hit 3 other locations, so a lot of time here. Soak in the future. Soak in the future. That's what it is. What? So this is DMG Mori, aka Space. Film it all.
Yeah, this is what the barrel tool, and this one is ball nose. This one is taking 22 minutes, and this one is taking 7 minutes with a stop over 1 millimeter.
Here we are at the joint open house. I think it's gonna be great. Oh, hey, John.
Come on in. I like impressive parts. You know what it is? It's a bone plate. So like, you know, you break your bone and then they screw it together. Even the logo is fully surfaced.
Yeah.
You know?
Like it looks gorgeous.
It's a whole different. See, but then that finish was just done with kind of a crappy end all fast. So that's fine.
But then look at how the logo looks.
Yeah, right? And here, this was all surfaced too, which is really nice.
Yes.
Like,
Yeah,
really,
that
really
looks
nice.
really good.
We mill it now. Rask bevels, man. Rask bevels, just like that.
Just machine them. We don't even need to grind them. That would be
You know what the
insane.
cycle time on one is?
Per blade, 32 minutes. Finish mill, 74 minutes.
Like that type of surface finish is going to take a long time.
Oh, yes. Last building, Ferro Technique. They sell Doosan machines and some other stuff. How's the show going so far, guys?
Great.
Fantastic.
Unreal.
Really cool. Walking into DMG Mori, it was like, what? It's like stepping into the future. Yep. All right, well, we got 22 minutes. Let's do this.
We have a TX and RX head on here, and it's a class 2 laser, and we were able to measure tools and tool breakage and scan tools just by breaking the beam itself, and we look for a status change on the NC control. I like it. All titanium on the shroud, is it?
Yep.
Man. All right, give me a clue. How do we retract it?
Well, it's the gold part.
Yep. Okay. Ah, look at that. That's slick. I like that.
It's crisp, eh?
Man, it's like there's no slack in that.
No, of course.
Yeah.
The tolerances are ridiculous that we have to hold to make that happen.
Yeah.
Interesting. Something like this one here.
What? You even see that?
Yeah, tiny.
Quarter of a turn. Try the other way. And then just
backwards.
That's it.
Oh, that's kind of cool.
Try to take it out. Just pull on a diagonal.
Slide it. Weird.
And then you can put any modular system you want on there to be able to. Yeah, no, just slide it in. There you go.
Whoa, that's super weird.
It's not going anywhere. I mean, you lock it in place, but even if you wouldn't lock it, it would hold, because once you've put it in, it basically locks itself.
So the TL is no sub spindle. The TT will have matching spindles, upper and lower turret, and then you can have milling on both turrets as well. You can have Y-axis on the top, but not Y-axis on the bottom. You can have Y-axis on both.
How was it?
It was really good.
Yeah. Behind the lens.
Yeah. It wasn't as tiring as last year.
Really?
Yeah.
Maybe for you.
I was just recording stuff.
No, it was amazing.
Yeah.
The knowledge.
Lots of stuff.
So much.
Lots of talking to people about everything.
And it's like more and more and more. Let's talk more, yeah.
I'm tired from knowledge.
Yeah.
On the table.
So that was the Joint Open House 2019. Thanks for watching, guys. See you next year.
Bye.
Say subscribe.
Oh. Subscribe.
All right. Appreciate you guys coming.
Subscribe.
Ring the bell.